Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. This is part 6 video on the chapter of squares and square roots. In this video, I will demonstrate how to find the square root of a non-perfect square number up to 2 or 3 decimal places. That is, the given number will not be a perfect square, and how we can use the long division method to find its square roots up to 2 or 3 decimal places. So if you have not watched the previous 5 videos on the chapter squares and square roots, I highly suggest and request that you watch them also to maintain the continuity of your study on the chapter of squares and square roots. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time, or this is the first video you are seeing, then I will strongly request and suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my very concise and very short quick notes prepared on the left hand side regarding how to find the square root of a non-perfect square natural number. We are not, the given number will be a natural number, it will not be a decimal number, it will be a natural number but it will not be a perfect square. So how to find the square root of such non-perfect square natural number up to some certain given number of decimal places. We will consider 2 decimal places and 3 decimal places. Okay, so let me first quickly check if everything is visible or not. Okay, so as you can see on the notes on the left hand side, there are basically 3 steps. The first step is that, so let's say you are asked to find the square root of the given number up to n decimal places, where n can be 2 or 3, or it can be 4. Let's say it will generally be 2 or 3. So we will discuss about, let's say we are asked to find n decimal places. So first step is append a decimal point to the given number and then append n plus 1 periods of zeros. One period of zero is this 0 0. A period means a pair of 2 digits, and a period of zeros means 0 0. So if n is 2, then we will add 2 plus 1, 3 pairs of 3 periods of zeros. This is the first period, this is the second period, and this is the third period. So we add whatever the number n is, we will append the decimal point, and then after decimal point we will add 3 periods of zeros. If we will add 3 if 3 periods of zeros if n is 2. If n is 3, then we will add, if n is 3, for n equals to, let's say, 2, and this will be, if n equals to 3, then we will have to add 4 periods of zeros, like this, 4 pairs of zeros, and then we will also create the periods in the given number n. So this is the first step. The second step is, so you can see some example. I have given 2 examples. 2, if the given number is 2, how we are creating the period of 3 periods of zeros after a decimal point, and then the number 2, the digit 2 remains alone as a also is the digit 2 is also a period. Similarly, for the given number 103, we are and for n equals to 3, we are appending 4 periods of zeros after a decimal point. So after decimal point, we see 4 pairs of zeros, and they are marked as period. And also the number 103, we also mark there the periods. So 03 will be the period, and the 1 will be the period. Okay. So the step 2 is, now we find the square root of this number, whatever number we obtained in step 1. We find the square root of the number obtained in step 1 with the periods using the long division method. So we have, after step 1, we have a decimal number that is we have a decimal point, and after the decimal point we will have all zeros appended, periods of zeros appended. We will find the square root of that number, decimal number, using the long division method, and then finally we will whatever the square root comes as the result, we will round that square root, round off the square root up to n decimal places. So if the square root, let's say for example, if the square root comes out to be 1.414 and 5, let's say, then, and if it was asked to find the square root up to 3 decimal places, then this square root we are asked to find up to 3 decimal places, n equals to 3, then this square root will get, if you round off the square root up to 3 decimal places, this becomes 1.414. So this way we will round off, the final step will be to round off the square root up to n decimal places. Okay, so that is all for the quick notes. There is nothing much. So let's try to find the square root of some numbers. So all the given numbers will be natural numbers, but since we are appending a decimal point and zeros, periods of zeros, it will eventually become a decimal number. So let's start with example 1. Let's say we are asked to find square root of 2, let's say up to 3 decimal places, up to 3 decimal places. Okay, so first what we do, we take the number 2, we put the decimal point, and then it is asked to find the square root up to 3 decimal places, so n equals to over here, n equals to 3. So we have to put append 4 periods of zeros. This is 1 period, this is 2nd period, this is 3rd period, this is 4th period. So we append the 4, that is n plus 1, 4 periods of zeros after a decimal point to the given number, and then we also mark the period in the given number. It will be 2. Now we start the long division method. Definitely we will start with the leftmost period, that is 2. It will be 1, divisor will be 1, quotient will be 1. 1 into 1 we have 1, and we subtract 1 from 2, we get 1. And then since all the numbers before the decimal point is exhausted, we have to put now a decimal point in the quotient also. Okay, now we bring the next period, append the next period to the remainder. Append the next period 0, 0 to the remainder, it becomes 100. Now 100 becomes the dividend, and the divisor, partial divisor, will be whatever the quotient is, ignoring the decimal point, whatever the quotient is 1, you multiply that by 2. So 1 into 2 is 2. So 2. Now I have to consider x. I have to put a decimal digit over here such that 2x, that is the number formed by 2-digit number 2 and another digit x multiplied by x will be less than equal to 100. So this will be implies that x has to be 4. So over here we will have 4, and we will also put this 4, append this 4 to the quotient, and 24 into 4 is 96. We take the remainder is 14. Okay, now we bring the next period, which is also 0, 0. Next period, and the next dividend becomes 1400. The next dividend becomes 1400, and the next partial divisor will be whatever the quotient is, ignoring the decimal point, which is 14 multiplied by 2, that is 28. Now again we have to find the digit x over here, so that 28x multiplied by x is less than equal to 1400. this will imply what will be x. Can x be 7? No. Can x be, what can x be? Uh, can x be not even 5? I think it will be 4. It will be 4. So, I could be wrong. I'm just trying it out. Okay. So, let's see what is 284 multiplied by 4. 16, 32, 33, 48, 11, 1136. 1136. Can it be 5? 40. No, it cannot be 5. 4. No, 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 no. Something is wrong. It cannot be 4. 1. After 4, it was 4. So 4, 96. Oh, this is not 14. This is 4. Sorry, this is 4. This is 4, and we brought the 0. So now what will be? This is 28x multiplied by x less than equals to 400. So this will imply x will be definitely 1. X will be 1. It cannot be 2. It cannot be 2 because 282 multiplied by 2 will exceed 400. So over here x has to be 1. Okay. So we have 1 over here, and then this 1 will also get appended to the quotient, and 281 multiplied by 1 is 281, and we find the remainder, which is 9, 1 and 1. 10, 10. Okay. So we have 119, and then we have another. We bring down the next period of zeros. We bring down the next period of zeros, and the dividend becomes 11900. So we will again proceed with the long division. Now the partial divisor will be whatever the quotient is, irrespective of the ignoring the decimal point. It is 141. 141 multiplied by 2, that is 282. Okay. 282. Okay. Now we have to find an x over here such that 282x multiplied by x will be less than equal to 11900. Okay. What can x be? X can be 5. 5. No, it cannot be 5. So let's try to see what if x can be 4 or not. 282 4 multiplied by 4. Let's see what it is. 16, 9, 32, and 11. 11296. Yes. So x is 4. X is 4. Okay. So this will be 4. This will be 4. 4 will get appended to the quotient, and we get 2824 multiplied by 4 is 11296. We take the remainder. We find the remainder, which is 4, 10, 6. I guess it is 604. 604. Okay. Now there is another period left. We will bring down the next period, and the next dividend becomes 60400, and the quotient becomes 1414 multiplied by 2, that is 2828. Okay. Now we have to see what digit we have to put here, so that 2828x multiplied by x will be less than equal to 60400, and I guess it will be 2. Let's see. 28282 multiplied by 2 is 4. 16, 5, 16 and 5. Okay, so x is this implies x is 2. So in the x will be 2, so we put x 2 over here, and also we append 2 in the question, and 282 282 multiplied by 2 is 5 6 5 6 4, and the remainder is 6 3 5 3. Okay, so this is the remainder, but we do not have any more periods left, so we are done with the long division method. So the final question is so therefore we can say that the square root of 2 is equal to 1.4142. 1.4142. This when rounded off to how many decimal places? 3 decimal places, rounded off to 3 decimal places becomes 1.414. So we just ignore, we take the after the decimal point we take the first 3 numbers, digits after the decimal point. So 1.41, 1.414, this is the square root of 2 up to 3 decimal places. So I hope the steps and the calculation is understood. Let's solve 2 or 3 more square roots, then you will understand completely. Okay, let's try exercise example number 2. Let's say find the square root of 10 up to 2 decimal places. Up to 2 decimal places. Okay, so first we have the number is 10, so we have 10 and n is 2 over here. We are asked to find the square root up to 2 decimal places. So as per the notes on the left hand side, the n is 2. Okay, so we will append 2 plus 1, that is 3 periods of zeros after the decimal point to the given number. So 3 periods of zeros. We added 3 periods of zeros after a decimal point to the given number, and then we will have to also mark the periods in the given number, that is 10, and this will be this. Okay, now we start the long division method. Definitely we will start with the leftmost period, that is 10, and the divisor will be 3, and the question will be 3, and we have 3 into 3 is 9, 10 minus 9 is 1. Okay, now since at this stage we have exhausted all the numbers before the decimal point, we have to put the decimal point we have to append the decimal point to the question. Okay, now we bring down the next period, that is the next 2 zeros, the next period to the remainder, and the remainder becomes the next dividend. Now what will be the partial divisor? Partial divisor will be whatever the quotient is, ignoring the decimal point, that is, it is 3, multiply that by 2. So 3 into 2 is 6. Now we have to find a digit x over here such that 6x multiplied by x is less than equal to 100. What can x be? X cannot be 2, so definitely x is equals to 1. So x will be 1, and 1 will get appended to the quotient, and 61 into 1 is 161, and we subtract 61 from the current dividend, that is 100, and we get 39. Okay, we bring down the next period, that is 00, and the new dividend and the new dividend becomes 3900, and the new partial divisor will be the current quotient multiplied by 2 ignoring the decimal point. So that is 62. That is 62. Now again we have to find the digit x such that 62x multiplied by x is less than equal to 3900. 3900. This will imply what will x be? Can x be 6? Can x be 7? No, I think x will be 6. Let's check it. 6 to 6 multiplied by 6 is 36, 12, 15, 37. Okay, so it is 6. So over here it will be 6. We write 6. We also append 6 to the question, and 6 to 6 multiplied by 6 is 3756. 3756. We find the remainder, that is 4, 4 and 1, 144. Now we have one more period left. We bring down the next period, append it to the remainder 144. It becomes 14400. This becomes the new dividend, and the next partial divisor becomes whatever the current quotient is multiplied by 2 ignoring the decimal point. That is 316 multiplied by 2, which is 12. Sorry, this 316 multiplied by 2 is 12, and 3 and 6. Okay, so now again we have to find x, the digit x over here for the divisor, such that 2x multiplied by x will be less than equal to 14400. What can x be? Can x be 12? Can x be 3? No, x cannot be 3 definitely. So this implies x will be 2, but anyway, let's check that out. 6322 multiplied by 2 is 4, 6 and 12. Okay, so x will be 2. X will be 2. I put 2 here. I append the 2 to the question. And 6322 multiplied by 2 is 12644, and the remainder is 6, 5, 5, 7, 7, 1, 1756, and there are no more periods left. We are exhausted. No more periods left. So the square root of 10 is 3.162, and we are asked to find the square root of 10 up to 2 decimal places. So if you round this off, rounding off to 2 decimal places, that is we will consider the first 2 digits after the decimal point. So the answer is 3.16. Square root of 10 up to 2 decimal places is 3.16. Okay. Let's try. What can we? Okay. I hope you got the idea how we are calculating the square root of a given natural number which is not a perfect square up to certain decimal places. That is, usually will be asked to find up to 2 or 3 decimal places. Let's do another last example. Let's say find the square root of, this is example 3. I am doing this. I am discussing finding the square root of a natural number which is not a perfect square up to certain decimal places, because this will be required in finding the square root of fractions and their decimal numbers. Okay, let's say find the square root of, let's say 128. Let's say 128 up to 3 decimal places, up to 3 decimal places. So as per the notes, the n is given as 3. Okay, so the number is 128. We have to find a square root up to 3 decimal places. So let's see how do we do it. So the number is 128. We put the decimal point, and then we will append how many periods of zeros? We will append 4, because n is 3. It has asked to find the square root up to 3 decimal places. N is 3, so n plus 1 will be 4. So we will have to append 4 periods of zeros. 4 periods of zeros. So we added 4 periods of zeros after the decimal point, and also we have to mark the periods in the given number, that is, mark the periods in 128. That will be 28 and 1. Okay, now start the long division method. So clearly the leftmost period is 1, the divisor will be 1, the quotient is 1, and we get 1 into 1, 1, and the remainder is 0. Okay, now we bring the next period, 28. So please be careful when to put the decimal point in the question. We are not yet exhausted of all numbers, all the digits before the decimal point. Now we will bring 28. The next period is 28. Append that to the remainder, and the next dividend becomes 28. And the next partial divisor will be whatever the current quotient is 1, that multiplied by 2. Whatever the quotient is, you have to ignore the decimal point in the quotient. Ignoring the decimal point in the quotient, multiply the quotient, current quotient, with 2. That will be the partial divisor in the next step. So 1 into 2 is 2. Okay, now I have to find x over here, such that we have to find x such that 2x multiplied by x. Now 2x does not mean 2 multiplied by x. 2x means a 2-digit number, where the digit at the tens place is 2 and the digit at the units place is x. So that number multiplied by x has to be less than equal to 28. So this clearly implies x is equal to 1. So x will be 1. I am replacing x with 1. I will have to append 1 with the current quotient. It will be 1, and 21 multiplied by 1 is 21, and the remainder is 7. Now at this point of time, we have exhausted all the digits before the decimal point. So we have to put the decimal point in the quotient. Now we have remainder 7. We will bring down the next period and append it to the remainder. That is, the remainder becomes 700, which becomes the next dividend. And what will be the partial divisor? Whatever the current quotient is, ignoring the decimal point, that is 11. 11 multiplied by 2 is 22. So 22. Now again, we proceed on with the long division method. We have to find x such that 2x multiplied by x is less than equal to 700. This implies x cannot be 4, so x will be 3, and 3 multiplied by 3 is 669. Okay, so x will be 3. I am replacing x with 3. 3 will get appended to the current quotient. So 3, and 3 multiplied by 3 is 669. Subtract that from the current dividend, and the remainder becomes 31. The remainder becomes 31. Okay, the remainder is 31. Okay, now I will bring down the next period and append it to the current remainder, which is 31, and the next dividend becomes 3100. The next dividend becomes 3100, and the next partial divisor will be whatever the current quotient is, ignoring the decimal point, multiplied by 2. So 113 multiplied by 2 is 226. Okay, so now again we have to find x such that 226x multiplied multiplied by x will be less than equal to 3100. So this implies x will be has to be 1. X cannot be 2, then it will cross 3100. So x is 1. Okay, so I am replacing x with 1. I am appending 1 to the current question, and 2261 multiplied by 1 is 2261. I will subtract that from the current dividend, which and the remainder becomes 9 3 8, I guess 839. Now I could possibly make any calculation mistakes. I'm not really focusing in that. If you see any calculation mistake, you can let me know in the comment section. I will appreciate that. But I will, after solving, this is the last example I will solve. I will check whether the answer is correct or not with using a calculator. So the remainder is 839, and we will bring down the next period and append it to the current remainder, and it will become, the next dividend will become 83900. Okay. The next partial divisor will be whatever the current quotient is, ignoring the decimal point, multiply that by 2. So it will become 2262. Now again we have to find x such that 2262 x multiplied by x is less than equal to 83900. So this implies, what can x be? Can x be 4? No, x cannot be 4. X will be 3. X cannot be 4. X cannot be 4. So it has to be 3. So 623 multiplied by 3 becomes 9, 6, 18, 7 and 6. Okay. So x will be 3. I am replacing x over here with 3. I am appending 3 to the current question, and 22623, the divisor, that is 22623 multiplied by 3 is 6, 7, 8, 6, 9. Subtract that from the dividend, 83900, and the remainder is 1, 3, 0, and then 6 and 1. 10, 10, 10. I think this will be 5. Now 10, 10, 9, 10, 9, 10, 13. Yes, now it is fine. So this, now we bring the next period, which is the last period, append that to the current remainder, which is 15031, and the next dividend becomes 1503100, and the next partial divisor will be whatever the quotient is, ignoring the decimal point, multiplied by 2. So that becomes 22623. Okay. So now again we have to find x such that 623 x multiplied by x is less than equal to 1503100. So this will imply what will be x? Can x be 7, 14? No, x 6. Yeah, I think it will be 6. Let's see. 2, 2, 6, 2, 3, 6, 6, 36, 15, 13, 37, 15 and 13. Okay. Okay. So x is 6. X is 6. This x will be 6. Okay. I am replacing x with 6, appending 6 to the current quotient, and 226236 multiplied by 6, we just calculated, it is 1, 3, 5, 7, 3, 5, 6. We take the remainder, even though the remainder is not necessary because we are already exhausted of all the periods, and definitely the final square root will be the quotient, that is 11.3136. But anyway, calculate the remainder. This is 4, 10, 6, 4 is 4, 7 is 8, 8, 8, 5, and this is 6, this is 4, and 1. I hope this is the remainder. Anyway, so therefore, we can say square root of, what was the square root? 128. 128, the final square root of 128 is 11.3136. 11.3136. Let me quickly check whether this is correct or not. The calculator will give more digits after the decimal point. So let's see, 128 to square root, it is coming 11.3137. 3137. We are having 3136. So maybe in the last step it could also be 7. Okay, so I did a mistake in the last step. Over here, 22623x multiplied by x less than equals to 1503,100. Over here, maybe not maybe, x should have been 7. So let's see if what 226,237 multiplied by 7. Let's see what it is. 49, 21, 25, 14, 16, 42, 43, 14, 18. Okay, so it is coming 158. 158. No, it is exceeding. How come? It is exceeding. Anyway, in my case it is coming 6. So these are I mean, if there is a little bit of difference in the digits in the 4th or 5th place after the decimal point, that really makes not that much of a difference. So as per my calculation, maybe the last step the x will be 7, but in my calculation it is coming 6. So if it is 7, do let me know in the comment section, then it is my mistake. But anyway, so as per my calculation, we are having the final square root of 128 as 11.3136. Okay, and we were trying to find the square root of up to 3 decimal places. So we will consider the 3 decimal places after the decimal point, and so this becomes so the square root of 128 up to 3 decimal places is 11.313. So I hope you got understood how to do the long division method calculation to find the square root of a natural number which is not a perfect square number. So you just append, depending on up to how many decimal places you have to find the square root. If it is n, you will create n plus 1 periods of zeros after the number, putting a decimal point, and then you will do the normal long division method, and so until all the periods are exhausted, the final quotient you have to round that off up to n decimal places. That will give the final answer. So in the next videos, I will explain about finding the square root of decimal numbers and fractions. That will bring an end, I hope, to the chapter of squares and square roots. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will provide the link to these notes, even though it is a very short note. I will provide the link to the PDF of these very quick notes in the description below. You can check that out. So that is all for this video. Thanks for watching, and until the next video, take care and bye.